All right, so next we're going to be looking at our Charles Law problem that I gave you. So, just like with Boyle's Law, it's important that our units for volume be consistent. And if you look at this, my milliliters and liters are not consistent. So I'm going to convert my milliliters to liters, which is just dividing by 1,000. So I'm going to use 0.752 liters. But I have another problem. For all gas laws, temperature must be in Kelvin. So I need to take my 25 degrees Celsius and I'm going to add 273.15. When I do that, I'm going to get 298.15, but I didn't have any decimal places on here, so I'm going to call it 298 Kelvin. So I have 3 sig figs from here, 3 sig figs, 3 sig figs. I can't use the 2 sig figs from the 25 because I added and rounded from there. And so that's going to be my 3 sig figs for my answer. Then I'm going to put this into my formula. So I'm going to have 0.752 liters over 298 Kelvin equals 1.25 liters over X. And the easiest way to solve these is to cross multiply. So I'm going to multiply these together. So I'm going to have 0.752 times X, and then I'm going to multiply these together, and that's going to be 298 times 1.25. And then I'm going to put it in my calculator like I did with Boyle's Law. So I'm going to say, okay, that this is 298 times 1.25 divided by 0.752. And I get out of my calculator 495. So X is 495 Kelvin. Okay, so for Charles' law, because it's a fraction, we are going to cross multiply and then solve it just like we did Boyle's law.